vector quantities. Scalar quantities are those which have magnitude but no direction, while vector quantities are those which have both magnitude as well as directions. Question first arises, what is a magnitude and what is a direction? First question is, what is a direction? Now, so when I say define a direction, that question sometimes feels weird. So direction, how do I define direction? So say if I am supposed to point towards northeast, what will I do? I will point a finger, I'll stretch my hand and point a finger. So what am I doing is, if I am in one location, if I am supposed to show northeast direction, I'll say northeast is somewhere out here. So how did I do? I pointed a finger. So first of all, a direction is a condition, a physical quantity. Again, a direction is a physical quantity, which is denoted by a line and an arrow. Any physical quantity which is denoted by a line and an arrow is known as a direction. Now, when we say directions, people misunderstand. How? For example, let us understand a scenario. Suppose I draw a quadrant system where I say this is east, this is west. And I say that rain is falling in this direction, 45 degrees. Rain is falling in this direction, 45 degrees. So most people would assume or would rather say, sir, that the rain is falling at 45 degrees southeast. Or they'll simply say southeast. Now understand, it's not southeast. Understand this. Say, assuming you are in India, when you are in India and you say the rain is coming from northwest to southeast. Obviously, if it is coming towards southeast, it means must be coming from northwest. For India, northwest is Pakistan. Rain does not come from Pakistan, guys. It comes from the clouds. ऊपर से आता है, नॉर्थवेस्ट से नहीं आता. नॉर्थवेस्ट इज हॉरिजॉन्टल, which means अगर आप हॉरिजॉन्टल पकड़ोगे, यानी कि this cannot be north. If I'm talking rain, this cannot be north. This is up. This is down. So this is not southeast, guys. This is down east. So our quadrants must be very, very clear. So take a left hand out. If you say left hand, it must be west. Right hand must be east. Front will be north. Back will be south. Up and then down. So east, west, always consider that to be your x-axis. South, north will be considered as y-axis, while up, down will be considered z-axis. So if you look at this plane, this is not xy plane. This is xz plane. So where question now arises, where is north? Question arises, where is north? The north is inside the paper, inwards. So if I was to denote north, I'll represent it as an X, which means it is going, the arrow is going inside. If I were to represent south, I'd represent it as a dot, which means it is out of the paper, upward. So again, X, Y-axis is inward, Z-axis. So now here's the best part. If you consider this, so both X-axis and Y-axis are horizontal lines. There's only one vertical line, which is the Z-axis. This is 90 degrees. This is also 90 degrees. Understand? The z-axis is a vertical line. So when I say this point, suppose if I make a line out here, 30 degrees. So how will I say? It is moving 30 degrees down of east. Down east, 30 degrees down east. So how do I say this? Acha, down of east or east of down, sir? It will be east of down. How do I say that? 30 degrees is here. So down comes here, east is here. So east of down, 30 degrees. So we need to understand this a lot. Say, if I say 37 degrees, east, north this time. So this time it's not xz, it's xy. If this is east, this is north, then where is up? Up is up. Dot. Down is inside the paper. Up is up out of the paper. So 37 degrees is 37 degrees north of east. If I make this line, say 37 degrees, then what will I say? 37 degrees east of north. How do I represent this? This is east of north, while this is north of east. North of east. How again? East से north की तरफ जा रहा है, तो north of east. East से north की तरफ. अब यहाँ पे north से east की तरफ जा रहे हैं, तो east of north. So this is what we mean by direction. This is what we mean by direction. So angles are very, very important. Directions, we need to be very clear what the question is saying. We'll come again to this question, the scenario. But first, we need to understand magnitude. This was one of the parts. A vector is a quantity which has both magnitude as well as direction. This was direction. What is a direction? A point denoted by from one point of reference with a line and an arrow. With a line and an arrow. What is a magnitude? Of the value to that quantity. What do you mean by value to the quantity? Units, basically. What is bigger? 10,000 newtons or 1 meter? Which is bigger? 10,000 newtons or 1 meter? You cannot represent this. So you cannot differentiate them because you cannot compare them because they are totally different units. They are for totally different properties. You cannot say which any of them is bigger. The amount of the quantity with which that particular physical quantity is represented. For example, if I say 10 meters without direction. So a scalar quantity is a quantity which has magnitude only. For example, so if I say energy has no direction. Energy has no direction. Work has no direction. Distance has no direction. Say if I'm taking my scooty and running all over a city without any sense of direction. So I have traveled a certain distance. The speedometer reading in your Activa or in any bike tells you the distance. It does not tell you the displacement. The question again, what is displacement? A particular direction, the shortest distance between any two points. Now, we'll be discussing those quantities later. But question is, what is a scalar quantity? Only magnitude, no direction. Vector quantities, magnitude and direction. Unfortunately, that was what you studied in the 9th standard. In 11th standard, there are a total of 5 physical quantities. There are a total of 5 physical quantities. First one is a scalar. Like we said, only direction, only magnitude, no direction. Then comes vector quantity. Third is a phasor. Fourth is a tensor. And fifth is a Psi. Make sure that you note them down. There are 5 physical quantities when it comes to 11th standard, out of which scalar, vector, and phasor will be studying in detail. When it comes to tensor, qualitative analysis only. Qualitative analysis only. And psi, there's only one term where you will see a psi quantity. You need to memorize it and then forget about it. There will be no calculations or no qualitative analysis about it. So now let's start with this. Scalars, vectors. Okay, what is a phasor? Now, with respect to a phasor, what happens is, I'll give you an example. Once Galileo was looking at a moon of Jupiter, and he sensed, according to him, Galileo, the moon of Jupiter was oscillating around Jupiter and not revolving around Jupiter. The moon of Jupiter was oscillating around Jupiter and not revolving around Jupiter. Now, obviously, right now, it's a online lecture. I cannot explain this. I cannot ask you a question regarding this. So, what will be the answer? What was he thinking? Obviously, moon will always revolve around a planet. So, we need to understand that if this is the moon of Jupiter, if this is Jupiter and a moon is supposed to revolve around us, if I'm looking from a far away distance, obviously Earth is from a far away distance, and I'm using a telescope, this moon is basically traveling like this, which I'll not be able to see. I'll not be able to see this curvature of the moon. What I'll see is that this moon is coming from this point. I'll not be able to see it entering inside and then coming back and then disappearing for some time and then coming back and then returning this. So with this, I can assume that it must be oscillating. So in other words, what Galileo was trying to say is he visualized a circular motion as an oscillatory motion, with which he represented an oscillatory motion can be seen as a circular motion, and a circular motion can be seen as an oscillatory motion. Such kinds of motion, where one form of motion can be represented as the other, or vice versa, is termed as a phasor quantity. It is not a vector. It is not because the directions are continuously changing. Even the directions are continuously changing in this scenario as well as in circular motion. So a circular motion cannot be considered as a vector quantity because it has no specific direction. The directions are continuously changing. The directions are continuously changing. Now, you must in 9th standard, that was one of the most stupidest questions you got. That if a man makes a complete revolution, work done was force into displacement. Work done was force into displacement. Now, displacement means that if a person makes a complete revolution from year to year, his displacement is 0. So if displacement is 0, work done is 0. Now imagine a car moving in a racetrack, making a circular motion in a racetrack. And you will say, sir, the displacement is 0. If a car is in a circular track, it's making a circular rotation, revolution. The displacement is zero, so its work done should be zero. अब work done zero है, energy zero है भाई. If work done is zero, which means energy loss is zero. भैया पेट्रोल नहीं चलना चाहिए. This was one of the, a pulley carrying load does not do any work. You also heard that. You'll say that does not make any sense. If you ask a coolie and you say he took your luggage and went a complete distance, and then you say you did not do any work, from where did that does not make any sense. So those quantities cannot be considered as a vector quantity, and hence you cannot get an answer using a vector quantity. Such scenarios require spaces. Anyway, 9th standard, there were a lot of conditions where things did not make any sense. Now, in physics, a very simple सा statement बोल रहा हूँ बच्चों, बहुत simple सा statement बोल रहा हूँ physics में. Anything that does not make any sense is wrong. So what you studied in a 9th standard, if it did not make any sense to you, it was a wrong statement. So a coolie carrying load does not do any work is itself a wrong statement. Similarly, a car revolving in a racetrack is not doing any work is again a wrong statement. Because that time, it is not about displacement, guys. It is about instantaneous displacement, which we'll be talking later. Now, such quantities where circular motion can be represented as an oscillatory motion. Similarly, an oscillatory motion can be represented as a circular motion. Such quantities are termed as phasor quantities. This is phasor. We'll be discussing this in detail, qualitatively and quantitatively. However, the fourth quantity is a tensor. This, for your 11th and 12th standard, is qualitative only, which means there will be no mathematical calculations. Now, for example, one of the most famous tensors. Achha, what is a tensor quantity? Multiple directions. Sir, this was also multiple directions. You could have called it. No. I'm talking about multiple directions in 3 dimensions. 3-dimensional multiple directions. Yes, phasor quantity is also a type of tensor. Similarly, a vector is actually a type of tensor. The simplest form of tensor is a vector, which means actually tensor is all of them, but at a different condition. What is a tensor? Multiple directions. For example, if I say a top, एक लट्टू को Beyblade is rotating. So what happens is when a Beyblade rotates, it just does not, the axis of the Beyblade does not rotate on the tip itself, the axis itself is rotating. For example, if I say कि एक wash basin में पानी चलाया, tap. It's not that direct tap से पानी नीचे गिर रहा है. It makes a beam. It makes one strand from one direction, another strand from another direction, third strand from another. There are multiple strands going in one niche sinkhole. Sinkhole में they become a cyclonic whirlpool, and then they enter down. So see, there were many directions in this case. Multiple directions. Similarly, if I say current, what is the direction of current? Current is not a vector quantity. Why? Think about it. Wire ऐसे जा रहा है, करंट ऐसे आया और ऐसे चला गया. सर, इसमें जो करंट फ्लो कर रहा है, what will be the shape of the current? Nobody knows. But because I can't see current, how do I know that there is a current flowing in this wire? Suppose this is a wire, this I connected to positive, this I connected to negative. And I say the current is flowing from positive to negative. How do I know current is flowing? I can't see it. So, sir, टच करके देख लो सर, झटका लगेगा. पहला तरीका. The first way is टच करके देख लो सर, झटका लग जाएगा, पता चल जाएगा करंट फ्लो कर रहे हैं. दूसरा, सर मंथ के एंड में बिजली का बिल आएगा, वो चेक कर लेना. So, there are only actually two ways to measure current. One, get a shock. Other, amount of energy consumption. Then, how do I imagine the shape? What will be the shape of the current? So, generally, when engineers imagine the shape of the current, they imagine a beam, the entire beam. Suppose this is a cylindrical wire, the entire current will be along the cylinder with a helix. This is the shape of the current, which means it again has multiple directions. Suppose, say a bullet, when fired, it does not go straight. A bullet, when fired, does not go straight. It rotates about its own axis. So there is a rotation as well as a linear motion, a straightforward motion. So again, it's a multiple direction. The better imagination will be an arrow. An arrow, suppose if I shoot an arrow, it's not going to go straight. This thing is going to rotate about its own axis while moving forward. It's like a drill. So if I look at this point, it is not only moving forward, it is rotating as well. So such motions are termed as multiple direction, tensor quantities. So current is neither scalar nor vector. It's a tensor. Similarly, a water strand in coming from a tap inside a basin cannot be considered as a vector quantity. It's not a vector, but it has directions. It has a multiple set of directions. Such quantities are termed as tensor quantities. Finally, so if we look at conditions, scalars, no direction. First among scalar, no direction. Number two, vector, single direction. Single direction. Phasors, planar, yani ki 2 dimension. It is still 2 dimension. This is 1 dimension. Vector is always 1 dimension. Phasors are 2D. Tensors are 3 dimensional, but multiple directions. Tensors are always 3 dimensional, multiple directions. And finally, we have psi. What is a psi? A 3-dimensional random motion. Molecules moving inside a gas. Molecules of a gas. Say if I put a gas inside a container, and if I try to choose a particular molecule and see its motion, it will be a 3-dimensional random motion. Such quantities, which can be calculated later, which will be calculating, such quantities are termed as psi quantity. Unfortunately, when it comes to psi quantity, you will be studying this concept only in chemistry. There will be termed as Schrodinger wave equation, during which you will get psi quantity condition, which you will be asked to memorize. Apart from that, you're not going to study psi. Tensors, you'll be saying that if you will not be using the word tensor, you will say it is neither scalar nor vector. Any quantity which is neither scalar nor vector will be considered as a tensor. Phasor, one motion direction, one type of motion represented as other type of motion, oscillatory or circular, will be termed as phasor. Linear motion, single direction motion will be termed as a vector. No direction will be considered as a scalar. I hope you have understood this concept. Now let's come to the main part of the topic, vectors. So what is a vector? Vector is a quantity having a magnitude and a direction. A magnitude and a direction. So what is a direction? So how do I represent direction? So for me, a direction will be an angle with respect to the positive x-axis. Yeah, x-axis could be anything. I'm not saying it's east. I'm not saying it's east. You have represented an x-axis, and from that x-axis, positive x-axis direction, this is positive x-axis, this is negative x-axis. From the positive x-axis, an angle represents a direction. So what is a vector? Now let's see a vector. When I say a vector is represented with an arrow on the top. When I say representing an arrow, arrow basically means that it has direction as well. Is a quantity having a magnitude. Magnitude, if I show without an arrow, it's a magnitude and a direction. This is a vector. This is how we represent a vector. A magnitude, comma, angle with respect to positive x-axis. That means if I say I will represent another vector B, then his angle will be represented like this, delta. So angle, I am not taking from here. I'm not taking from here. I'm still taking it from the positive x-axis. So a B vector, see again, B vector, which means representing a B vector, basically means there is an arrow on top, represented by its magnitude or the length, basically, and its angle, delta. Similarly, even if I use this vector, C, I still have to take this angle, this entire angle. So the angle must always be measured anti-clockwise. Angle must always be measured anti-clockwise. So C vector, I don't need to show C arrow on out here. I need to show C vector as C, comma, angle phi. Again, this angle must be measured anti-clockwise. So suppose, so it is easier to take this angle. Why will I go entire rotation? You can take this angle. The only thing is, if I say this angle, some other term, say gamma, then this angle will not be considered as gamma. It will be seen as C, comma, minus gamma. So that means basically angle must always be measured counterclockwise or anti-clockwise. Clockwise angle will be treated as negative. Angle will be treated as positive. Anti-clockwise angle will be treated as positive. Clockwise angle will be treated as negative. So if I say this is say 300 degrees, I can write it as minus 60 degrees. Of course, one entire rotation is 360. So if I say this is 300 degrees, say example. So I write it as C, comma 300 degrees, or I can write it as C, comma minus 60 degrees. It's one and the same. But yeah, if you write C, comma 60, that is wrong. 60 is above the x-axis. Minus 60 is below the x-axis. So suppose I say there is a vector 10, comma 210 degrees. How do I represent this? Any numbers, a vector is 10, comma 210 degrees. How do I represent it in an x-axis? So I'll make as an x-axis, y-axis. From year to year, this is complete 180, and this is 270. So 210 will be in the third quadrant. This is the first quadrant, this is the second quadrant, this is the third quadrant, this is the fourth quadrant. So 180 plus 30 degrees will be somewhere out here. So I make a line which is of 10 units. And this angle, this particular angle will be around 30 degrees. So this will become 10, 210 degrees. This is how we represent a vector. 10 units. So what is 10? Basically 10 units. It could be 10 centimeters, it could be 10 meters, it could be 10 newtons, it could be 10 meters per second. Doesn't matter. It's 10 units. One more important thing. Say if I have another vector B, which is say 5 units at 30 degrees. So 30 degrees is just the vertically opposite of this, but its length is 5. It's 5 units. So now you cannot use scale and every time. So what you are going to do is approximately make sure that your value is half this value, approximately. Try and take an approximation. So if I'm saying this is 10, if this is 5, make sure it looks at least half of this. So this is 5, 30. This is how we represent a vector in a diagram. This is algebraic representation of a vector. This is diagrammatic or geometric representation of a vector. This is an algebraic representation of a vector. This is a geometric representation of a vector. Now, most important thing. Up till 10th standard, when you were studying maths, there was an extra topic for algebra. There was an extra topic for geometry. But from now on, anything that I must tell you this, that any calculation which is based on geometry can easily be solved using algebra. And similarly, any question based on algebra can easily be calculated using geometry. So for us, geometry and algebra are not two separate things. They are one and the same thing. We can use both of them together, whichever we feel as important. So now let us come to this scenario. This vector, A vector, I said it has a magnitude and a direction. So it was represented. It was represented by a line and an angle, by a length and an arrow. Now, if you look at it this way, suppose I draw a coordinate system. Now, logically, if you see it this way, this has a certain x coordinate, let's say A, and this has a certain y coordinate as well, B. There is an x coordinate. Say this is x, this is y. I don't know. Let's say this is y. So if this is A, there is a certain x coordinate, and there is a certain y coordinate, which means the coordinate of this system, if I say B, is x comma y, which means x coordinate is A units and y coordinates is B units. So I can say this coordinate must be A comma. So the very important condition is that a vector can be represented not only as a magnitude and a direction, but also by its coordinates. Because if I have the coordinates, I can easily calculate its magnitude and direction. So my representation of vector not only requires a magnitude and a direction, it can also be shown by its coordinates. So this is one of the most important conditions of today, that a vector can be represented in two formats. Two formats. The polar form which is basically magnitude and direction. A vector as a magnitude and a direction. Magnitude and another is known as the Cartesian form. Or sometimes known as the rectilinear form. Why rectilinear form? If you look at it, it is always making a rectangle. If you look at it, this section is always making a rectangle, hence a rectilinear form. Is represented using its coordinates. Now we have a problem. When I say coordinates, now let us understand the significance again. There is a certain vector. I am showing it in the first quadrant. It could be in any quadrant as such. A vector, this is theta. This has A, this has B. This is represented as A comma B. I have already used a comma in polar form. I have already used a comma in polar form. A comma B की बात कर रहे हैं. So I can't use this as a comma. If I say A comma B, the moment I say comma, I have already shown polar, which is a magnitude, which means A will become magnitude, B will become direction. We cannot do that. We cannot use comma. So what do we do now? How do I represent this? So I can say, on the other hand, is that this point is a combination of A and B. This point is a combination of A and B. So combination का दूसरा टर्म क्या होता है बच्चों? एडिशन. तो कॉम्बिनेशन का दूसरा टर्म क्या होता है? A plus B. But we cannot use A plus B. What does that mean? Because A is along x-axis, B is along y-axis. So I must say A, it is a combination or addition of A in x-axis and B in y-axis, maybe z-axis. So this representation, how do I represent an x-axis? So I represent that x-axis using I cap and B as J और उसके ऊपर एक छोटी सी टोपी लगा दो. AI cap plus BJ cap. That is, it's a combination of A along x-axis and B along y-axis. So there can be C along z-axis. So let us understand this condition. This is plus x-axis. I represent it as plus I cap. This is negative x-axis. I represent it as minus I cap. This is plus J cap. And this is minus J cap. So what is this? It is representing a certain axis or a certain line. So what these terms, I cap, J cap, and for Z axis, I can use K cap. See, K cap, let's say. So what are these guys? These guys are known as unit vectors. So what does a unit vector mean? Unit by basically means one unit. So how does it have a unit value, sir? See, A into 1 is still A. So if I say A along x-axis, so A magnitude hai, or 1 into 1 unit of along x-axis is still A values magnitude along x-axis, B along y-axis, and C along z-axis. Say if there is a C. Such values. So what is a unit vector? A unit vector is a vector. Again, a unit vector is a vector whose magnitude is 1 in a specific direction. Whose magnitude is 1 in specific direction. Now there is a problem with this. Suppose I say there is a vector B, which I write it as minus 1 I cap. I can write it as minus I cap also. Doesn't matter because its magnitude is still 1. Minus I cap. So I will not say that its magnitude is minus 1. No, its magnitude is still 1, but along minus x-axis. So this time, the minus sign will not indicate the magnitude. It will indicate the direction. So in a vector, you need to note this down. In a vector, the negative or positive sign does not indicate a magnitude. It always indicates a direction. So in a vector, magnitude cannot be negative. In a vector, a magnitude cannot be negative. There is no negative value in it. A negative sign in front of a vector will always indicate magnitude, direction, and not magnitude. Suppose. So in a sense, say if I say a vector is minus 3 I cap plus 4 j cap. Minus 3 I cap plus 4 j cap, Cartesian form. Coordinates दे दिए -3 and 4. So -3 is not the magnitude, 3 is the magnitude. Again, I'm repeating. So 3 along minus x-axis, this is 3. So how do I represent this vector? Sorry. 3 along minus x-axis, this is 3, not -3. And 4 along plus y-axis, this is 4. Now here's the mistake most students do while representing this vector. This is not my vector. Vector starts from the origin. Vector will always start from the origin. So how do I do this? 4, 3, 4. This is not the line. 3 and 4. This is the point. Minus 3, 4. This is my vector. 3 I cap and 4 j cap. I hope I make myself clear with this. So similarly, if you see, this is 3, this is 4. This is not my vector. This is not my vector. This is my vector. Which means हमेशा y axis से एक लाइन ड्रॉ करोगे, x axis से एक लाइन ड्रॉ करोगे, जहां पर वो मीट करते हैं, ओरिजिन से वो वेक्टर लोगे. ओरिजिन से वो वेक्टर लोगे. Now, so a vector must be represented using, can be represented by using polar form or a Cartesian form. Polar form, basically magnitude and an angle. Cartesian form, basically the coordinates. So, I say, I have a vector A, which is minus 6 I cap and minus 6 j cap. Or rather, let's say this time, let's make a mistake. Let's say minus 6 k cap. सर k cap को कैसे represent करेंगे? कोई problem नहीं है बच्चों. Same story. X axis, Y axis बनाओ. भाई, लेकिन X axis, Y axis नहीं है. This time this is X axis and this is Z axis. Same line बनाओ, कोई दिक्कत नहीं. Y axis हटा दो. अब -6 यहाँ पर ये -6 होगा, नहीं, ये 6 होगा in minus X axis. फिर से, this is not -6, this is 6 in minus X axis. Similarly, this is 6 in minus Z axis. Then this is the vector? No, this is not the vector. This, we draw a line from here, we draw a line from here, and then we draw a line out here. This is my vector. I hope ये concept तुम लोग को समझ में आया. This was all about representing a vector in two forms, polar form and Cartesian form. So now here's the thing. Now here's the thing. I am saying that this is a vector. It has coordinates, which is basically -6, -6. This must be having a magnitude. Obviously, since it's a vector, it has a magnitude. And there is an angle. This is the angle. Which means I can measure its magnitude as well as direction. I can represent this vector using its magnitude, its length, which in this case is a square, which means this must be 6√2. So I can say that this, and since this is a square, this angle must be 45 degrees. I can say that this vector is same as writing 6 root 2 along how much angle? 180 plus 45 degrees, 225 degrees. Those who did not understand this, what I did, please understand. 6 and 6, these are the coordinates 6 and 6. This basically, if I am drawing a rectangle, this is also 6, this is also 6, this is a square. And this is basically a diagonal of a square. So if I say this is 6, this is 6, a diagonal of a square is at 45 degrees from here. And secondly, if I use Pythagoras theorem, it will be 6 root 2, this length. So this is from negative x-axis 45 degrees below and at 6 root 2. So 45 degree, now I said that when I measure angle, it must be from positive x-axis only, not from negative x-axis. Which means this angle must be 45, and from here, this angle from here to here, it's 180 plus 45, that is 225 degrees. So here's the thing, I represented the same vector which was in Cartesian form, in polar form, which is magnitude and direction. So if a vector, if it is represented in Cartesian form, can be written in polar form. Similarly, if a vector which is in polar form can be easily written in Cartesian form. So representation of vectors can be polar or Cartesian, and one form of representation can be seen as other form of representation. We can convert one form of representation of vector to other form of representation, which I'll be teaching you in the next lecture. Kotule sir, we can stop it.